Good day, everyone. Welcome once again to our class in Math 051 Engineering Calculus. So today we are going to continue our review on functions. So this is the part number 3 of our review of functions. So this morning we are going to discuss the square root functions. The function f defined by this expression f of x equal to the square root of p sub x plus k, where p is a polynomial in x, is called the square root of square root function. The domain of square root functions is the set of x such that p sub x greater than or equal to 0. So the graphs of square root functions can be semicircles, semiparabolas, or semi-hyperbolas. So let's take this example here. So we are given this function f of x equal to the square root of x plus 1. So we are asked to sketch the graph of the function, and also we are asked to find the domain and range. Alright, so from the condition, we need to have the p sub x greater than or equal to 0. So what is that p sub x? That is the radicand. So in this example, our p sub x is equal to x plus 1. Okay, so the condition for this, it must be greater than or equal to 0. Okay, so to solve for x, let's subtract both sides by 1. So we have x plus 1. Then you have greater than or equal to 0. So take note that the rule in inequality, when you add or subtract, it won't change the direction of the inequality. So to solve for x, let's subtract both sides by 1. So 1 minus 1 is 0. So what is left in the left side is x. X is greater than or equal to minus 1. Okay. Now if you want to see the graph of this function, so we'll just apply the same technique as mentioned in our previous review in our part 1 and part 2. So there are steps there to follow in graphing the function. So you just need to uh, assume value for x, and of course your assumption should belong to this solution here. Okay, so you have x and you have f of x, then you tabulate the values. Okay, so when x is equal to minus 1, so what is your f of x? So when x equal to minus 1, our f of x is equal to, so minus 1 plus 1 equal to 0 square root of 0, that is also equal to 0. So what other values that is greater than minus 1? So if we consider 0, when x equal to 0, so you have 0 plus 1 is 1, square root of 1, that is also equal to 1. Let's try another value. Okay, so if you put this in the number line, so this x greater than or equal to minus 1. So if you look at it in the number line system, okay, so this is our positive infinity, this is our negative infinity. So assuming this is our 0, assuming this is our, say, negative 1, okay, we have positive 1, can have positive 2, positive 3, positive 4. Okay, so let us try these values. So we cannot try values on the left side of negative 1 because if you say, for example, if you try minus 2 here, okay, so if you try this one, what will happen? When this is minus 2 plus 1, that is negative 1, square root of negative 1, so that's a negative, right? So the condition is the p sub x, meaning the radicand must be greater than or equal to 0. So you cannot use this value. So you just assume values that is covered from this values for x. So if you x equal to 1, so this will be square root of 2. 1 plus 1 is 2, square root of 2. Then when x equal to, say, 2, so we have f of x equal to square root of 3. Alright, square root of 3. And if you have, say, your x is equal to 3, then you have 3 plus 1 is 4, square root of 4. So we have 2. Alright? So when you graph this, so this is our 1, this is our 2, this is our 3, so assuming this is our 1. Okay, so let's take this 1, 2, and 3, and you have here negative 1. Okay, so when x equal to negative 1, our f of x is 0, so we have a point here. Then x equal to 0, f of x is equal to 1. Okay, so we have it here. When x equal to 1, square root of 2, what is square root of 2? Square root of 2 is 1 point something, no? So when x equal to 1, square root of 2, 1 point something, so approximate natin somewhere here. Okay, so approximate, and when x equal to 2, so square root of 3, square root of 3, that is 1 point something also. So I think it's somewhere here. And when x equal to 3, so we have f of x equal to 2. So f of x equal to 2, so it's somewhere here. Okay, so when you connect these points, so you'll have this semi-parabola. Okay, so you continue that one. So that's our graph. So to find the domain, so what is our domain here? So if you look at the solution, which is x equal to greater than or equal to -1. So looking at the number line, so it means that the solution is in this interval, right? So going to the right. So it's belong to this interval here. Okay, so we have -1, okay, and positive infinity. Alright, you cannot use the negative value after -1 because it will give the radicand a negative. So square root of a negative is not allowed. Okay, so the domain therefore is since -1 is included, so this should be something like this. So -1 is included. So the domain therefore is -1, and we have the positive infinity. Okay, how about the range? So how will you solve for the range? So the range is, so as you see here, as you continue filling up the value for x, so we have here the range from 0 to, it will also go to the positive infinity. Okay, so therefore, and 0 is included. So the range therefore is from 0 to positive infinity. Okay, so any question? Any question? So the hint to find the range class, you just use the same expression here. So we know that y is a function of x. Okay, so y is a function of x. Ang value ng y magdepende sa value ng x. Okay, so we can have, since y is equal to function of x, so we can have y equal to the square root of x plus 1. Okay, now if we square both sides, so squaring both sides, so we have y squared equal to square root of x plus 1. So you square this. So we know that this square root here, the root here is 2. So you have 2 here, then you have the exponent 2. So that cancels out. So we have y squared equal to x plus 1. Okay, so from here we can solve for x. So to solve for x, you just subtract both sides by by 1. So you have y squared, um, so y squared minus 1. Sorry, let's move it to the other. So move it here. So y squared, so subtract both sides by 1, equal to x. On the right side we have x plus 1, and we also have to subtract it by 1. So therefore, so 1 minus 1, so this would be 0. So we have x equal to y squared minus 1. Or you can say x equal to y squared minus 1. Okay, so now if you assume value for y and solve for x, so from here, if for example when y is equal to, okay, so let's assume values. When y is equal to 0, so we can solve for the value of x. So what is the value of x? So when y is equal to 0, so our x is 0 to, so 0 minus 1, so we have x equal to minus 1. Or if you have y equal to, so we just assume values, no? Or here, values for the vertical components. So when y is equal to, say, 1, so when y is equal to 1, so what is our x? Okay, so when y is equal to 1, so 1 squared minus 1, 1 squared is 1 minus 1, so we have x equal to 0. Okay, so exactly this one. When y is equal to negative, when y is equal to 0, our x equal to negative 1, this one. When y is positive 1, so here, this is our y. When y is positive 1, okay, this is y equal to fx. So this is our x-axis. Okay, so when y is equal to 1, so our x is equal to 0. So exactly this one. Or if we have y equal to, say, 2, when y is equal to 2, so what is our x? You just substitute it here. When y is 2, x is 2 squared 4 minus 1, so this is 3. Okay, so when y is equal to 3, so what is our x? So our x is, so y squared, which is 3, 3 squared 9 minus 1 is 8. Alright, so when when y is equal to, say, 4, so what is our x? So 4 squared So substitute it here. So 4, y is 4, 4 squared 16 minus 1, this is 15. Okay, so when y is 5, so 5 squared minus 1, so what is our x? So when this is 5, 5 squared 25 minus 1, so we have 24. So you see the pattern here. So it will go on and on. So that's why we have here the value of y will go up to or approaches infinity. So it will give the value for x corresponding for x, corresponding value for x. So that's why we have here the range is from 0 to x 0 is included. It gives us the value here when y equal to 0. This is the result of our calculation. Here x must be greater than or equal to minus 1. So this is included. Okay, so the range is 0 in this interval from 0 to positive infinity. Alright, so I hope it's clear with you. Okay, so this is the details of the answer for this example. You're asked to graph the function, and you're asked also to find the domain and range. So these are the solutions. These are the steps, no, in arriving at our domain and also the range. So next we are going to uh, have another example here. So same topic for squared function. So another problem is sketch the graph of the function. Also find the domain and range. So this time we are given f of x equal to the square root of 9 minus x squared. Alright, so same procedure. We keep in our mind that the rule here is to make the radicand greater than or equal to 0. So we'll begin with looking at the value of x from this radicand. So 9 minus x squared. So from the concept that was discussed, it must be greater than or equal to 0. Okay, now our goal here is to find the value of x. So let's segregate x on the left side and the other uh, item on the other side. So we'll subtract both sides of this inequality by 9. So we have 9 minus 9 and minus x squared. Okay, so we have the original here, that is 9 minus x squared. No? 9 minus x squared. Para matanggal natin yung 9 sa left side, we have to subtract it by 9 also. Then to retain the inequality, in the rule of inequality, uh, we we cannot change the sign of inequality when you subtract or add on both sides, so it will remain as greater than or equal to, so 0. And what we did in the left side, we also have to do it on the right side, so 0 minus 9. Okay, so 9 minus 9, this is 0. Okay, so this will be 0. So on the left side, we have only minus x squared. right? Minus x squared greater than or equal to minus 9. All right. And then we have a rule in equality that if you add or subtract, it won't change the sign of inequalities. But if you multiply or divide by a negative number, it will change the direction of the inequality. So we'll apply the rule here that assuming that A, B, and C are real numbers. Okay, so they are all assuming they are real numbers. So can you still remember what are real numbers? So assuming that A, B, and C are real numbers. So what are real numbers? So when you speak of real numbers, those are numbers that can be plotted on the number line system. Alright, so assuming that this is our number line system, so negative infinity, positive infinity here, assuming this is our 0, assuming this is our 1, 2, and so on and so forth. On the other side we have negative 1, negative 2, and so on and so forth. Okay, so any numbers that can be plotted on this number line system can be considered as real number. It can be positive, negative, it can be decimal. Okay, so in short, when we speak of real numbers, that is composed of terminating decimal, non-terminating recurring decimals, and non-terminating non-recurring decimals. So the terminating decimals and non-terminating recurrent decimals, they're called rational numbers. Okay, and then the non-terminating, non-recurring decimals are called irrational numbers. So in short, when you speak of real numbers, um, these are rational numbers plus the irrational numbers. So what are those terminating decimals? For example, we have 0.375. So the number terminates. So these are fractional, right? So that's why it's called rational. If you have a ratio that will give us 0.375 and terminates at these three numbers, and then we have the, for example, 0.6666. So non-terminating and recurring decimals. So that's an example. Both of these are rational numbers. But if you have square root of 2, which is equivalent to 1.414 dot dot dot, so that's an example of irrational numbers. So when we talk of real numbers, so these are rational numbers plus irrational numbers. So those numbers can be plotted in number line. For example, 0.375, that can be plotted in the real numbers. So where is it 0.375? So if this is 0, this is 0.5, so it's somewhere here, right? 0.666, so if this is 0.5 here, this 0.5 here, 0.666, so somewhere here, right? And then square root of 2, that is 1.4 something, 1.414. So 1.4, so if this is 1.5 here, so it's somewhere here. So it can be plotted. So therefore, real numbers are those numbers that can be plotted in the number lines. Okay, so just a short review of real numbers. And then to continue with this, we have assuming that A, B, C are real numbers. If you have, say, A greater than B, alright? Now, if C is negative, assuming C is negative, okay, so negative. So for example, if you have A, assuming our A is equal to, say, 6, assuming A is equal to 6, and our B is, say, equal to 4. So both of them are positive, and let's say our C is equals, so negative, like negative 2, for example. Okay, that is negative 2. So from here we have 6. Of course, this is A greater than B, so it's true, right? 6 greater than 4. So we have 6 greater than 4, right? Is it correct? Okay, so mas malaki ang 6 sa 4. Now, if C is negative, if you are going to, for example, multiply. So ito yung rule, class, the rule in inequalities. So if you have A, assuming A and B and C are real numbers, if you have A greater than B and C is negative, so negative ang C, okay, so C is negative, then if you have to multiply, say A multiplied by C, which is negative, so times negative C, so the sign of this inequality will change direction. So this becomes like this. Then you have also B times negative C. Okay, so ito yung role ng multiplication of inequalities. It changes the direction if you multiplied both sides of the inequality by a negative number. And that's the same as when you do the division. So when you do the division, like if A is greater than B, A is greater than B, okay, so again A greater than B and C is negative. So if you divide A by negative C, so this also changes the direction. So this becomes less than B divided by C. Okay, so to illustrate that, so we have here the example. So if A equal to 6, B equal to 4, C is negative 2. So if you are going to multiply 6 multiplied by negative 2, so it will change the direction. So instead of greater than, this will be less than. Okay, so we have B is 4. B is 4 multiplied by negative 2 also. Okay, so what is negative 2? Sorry, 6 times negative 2, that is negative 12, right? So negative 12, is it greater than or less than negative 8? Is it right? So it is less than. So in the number line system, the closer is the number to the 0. So for example here, okay, I'll just draw another one. So assuming this is our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is our negative 12 here. So the other one is negative 8. So 11, 10, 9, 8. So this is our negative 8. Okay, so the rule here is that the closer is the negative number to the 0 in the number line system, the bigger it is. Alright, so you remember that. That's why. So when you have this inequality, 6 times 4, when you divide it or when you multiply it by a negative number, so it will change the direction. Right? So we have negative 12 less than negative 8. In similar manner, if you divide, so if you have 6, this is our A, you divide this by negative 2, our C is negative 2, so divide it by negative 2, and our 4, when you divide it by negative 2, so the result would be, here we have minus 3, right? Then here becomes minus 2. So originally we have 6 greater than 4, but when you divide it by minus 2, it changes the direction. It becomes like this. So it's right, because minus 3 is less than minus 2. So where is it? If this is our minus 2 here, this is our minus 2, and this is our minus 3. So we see here that minus 2 is closer to 0, right? So 2 is closer to 0, therefore minus 2 is greater than 3, or minus 3 is less than minus 2. So we are going to use the same concept in dealing with this inequality here. Okay, so if you multiply or divide both sides by, say, negative 1, so ang purpose natin class is to make this positive because both sides is negative. So it will, so when you divide or multiply both sides by negative 1, so this becomes x squared less than or equal to 9. Alright, so you have two values here for x, that is plus or minus 3. So x greater than or equal to plus minus 3. Okay, so now if you look at, so we'll add here, make it minus 3. So to find the domain, so how will we find the domain here? So our domain, so we can check now. You just substitute the value within this. Okay, so domain Okay, so the domain is here. We have x. If you look at this one, let's consider this minus 3, positive 3. Okay, so let's assume values. So for example, if you have, say, assuming that you have minus 4 here and then you substitute it here. So 9 minus 4 squared. So minus 4 squared is 16. So 9 minus 16, negative 7. So cannot be. So the values to the left of minus 3 is excluded in the domain. How about if x equal to positive 4, meaning number after this positive 3. So here, so this is 4. Okay, so we have tried already negative 4. Negative 4, substitute it here. So negative 4 squared, positive 16. So 9 minus 16, negative. So this number cannot be included, so excluding the domain. How about 4? So when x equal to 4, so we have 4 squared, 16. So 9 minus 16, that is still square root of minus 7. So we cannot include this. But if you have, say, x equal to minus 3, so when x equal to minus 3, minus 9 minus 3 squared. 3 squared is 9. So 9 minus 9 is 0. So square root of 0 is 0. So therefore, we can include the value 3. If you have, say, negative 2. So 9 minus negative 2 square. Negative 2 square is 4. 9 minus 4, that is 5. Okay, so kasama to. When this is 1, negative 1. So negative 1 square is 1. So 9 minus 1. So that would be square root of 8. So this is also allowed. When x equal to 0, x equal to 0, 0 squared 0, 9 minus 0, 9. Square root of 9 is 3. Okay, so 0 is included, and so on and so forth. If you have positive 3, so 3 squared, 9. 9 minus 9, 0. Square root of 0 is 0. So 3 is included. So therefore, so the domain, so we have here the domain, negative 3, positive 3. Okay, so that's the domain. Okay, so to find the range, we will again use this expression here, and we know that y is equal to f of x. Okay, so y is equal to f of x. Alright, so we are going to use this f of x. Okay, so from this expression, so we know that y equal to f of x, so we can say that y equal to the square root of 9 minus x squared. Okay, so if you are going to square both sides, so squaring both sides, so we have y equal to, so square of the square root of 9 minus x squared, so the index here, which is 2, and the exponent, which is 2, cancels out, or that's equal to 1. So what is left here is we have 9 minus x squared. Okay. By the way, remember that this function is a half circle. Okay, so to prove that one, what you're going to do is just assume value for x, solve for f of x, and then plot those points, and you will form a semicircle. Okay, so from here, we are going to solve for x. So we can rewrite this also as 9 minus x squared equal to y squared. Okay, now to solve for x, let's subtract both sides by 9. So this would be 9 minus 9. So 9 minus 9 is 0. Then we have minus x squared. So what we did in the left side, we also have to do it on the right side. So y squared also minus 9. Okay, so there is this part. So we have 9 minus 9, 0. So what is left is minus x squared equals 9 minus, y minus y squared minus 9. Okay, so solving for, this is minus. Okay, so now we need positive x squared. So we are going to multiply or divide both sides by negative 1. So when you multiply or divide both sides by negative 1, by the way, this is, we're talking of inequality here. Okay, so the condition here is that 9 minus x squared must be greater than 0. So this must be greater than or equal to 0. Okay, so this is our inequality here. Okay, so this must be greater than or equal to this. Okay, sorry, let me do it again. So this is 9 minus x squared. Okay, so this is our function. So we can write it y equal to square root of 9 minus x squared. So squaring both sides, we have y squared equal to 9 minus x squared. Okay, so the condition is that 9 minus x squared must be greater than 0. So 9x squared must be greater than 0. So from here, Okay, so we have okay, let's solve for x here. So to solve for x, we subtract both sides by 9. So we have y squared minus 9. Okay, so we do the same thing on the other side. So we have 9 minus x squared, then minus 9 also. So we have 9, so this 9 here, and this 9 equal to 0. So 9 minus 9 is equal to 0. So y squared minus 9 equal to minus x squared. Okay, so our x squared is negative, so let's make it a positive. Okay, so we have if you divide this both sides by -1, so this would be negative y squared, divide or multiply by -1 plus the same result. So this become plus 9, right? Then equal to positive x squared. Or you have 9 minus y squared equal to x squared. Or you have x squared equal to 9 minus y squared. So they're just the same. Okay. Now to solve for x, let's take square root on both sides. So taking square root on both sides, so we have x equal to, so take square root on both sides, you have two values for the right side. You have plus and minus square root of 9 minus y squared. Okay. Now the same condition, solve for x, the radicand here, 9 minus y squared, must be greater than 0. So 9 minus y squared must be greater than or equal to 0. So solving for y, so let's subtract both sides by 9. So we have 9 minus y squared, then subtract it with or by 9 greater than equal to 0. So we also have to subtract it by 9. Okay, so we have 9 minus 9, so that is 0. So what is left on the left side is minus y squared equal greater than or equal to 9. Negative 9, sorry. Okay, so again we have here an inequality. Um, so to solve for the positive of y, we have to divide. Either you have to divide or multiply by negative 1. So if you divide or multiply by negative 1 both sides, so we will have y squared. So it changes the direction, less than or equal to positive 9. Okay, so solving for y, we have y. So you have to take square root on both sides. So we have y less than or equal to plus and minus 3. Plus and minus 3. Okay, so what does it mean? Plus or minus 3. So when you draw that in the number line system, okay, so I have no space here. Perhaps I can do it here. Okay, I'll take this space here. So now we use the vertical line. Okay, so this is 0. So we have, say, 1, 2, 3. 0, positive 3. We have negative 1, negative 2, negative 3. Okay, so we have 3 minus 3. So 1, 2, 3. Negative 1, negative 2, negative 3. So take note that our function f of x square root of 9 minus x squared is a semicircle. So to determine if that's really a semicircle, so we can assume values for x and solve for y or f of x, and then after that you plot the points. Okay, so let's have this table here. So in x equal to, say, here we have negative 3 using this, y equal to f of x or f of x equal to square root of 9 minus x squared. So when x equal to negative 3, so what is our f of x? When negative 3, so this is 0. Okay, so when x equal to minus 3, 0 ang ating f of x. So it's here. When x equal to minus 2, okay, we're using this value here, now in this interval, the domain. So in minus 2, so 9 minus 2 squared is 4, so 9 minus 4 is 5. That's square root, so this is square root of 5. What is square root of 5? So we can approximate square root of 5 is that is 2 point something. So when x equal to minus 2, this minus 2 here. So 2 point something, right? So if this is 2, so minus 2, so 2 point something, so somewhere here. Okay. Then when x equal to negative 1, when x equal to negative 1, so this is negative 1 squared, 1, so 9 minus 1 is 8, so this would be square root of 8. So what is square root of 8? So square root of 8 is, square root of 9 is 3, so square root of 8, so that is 2 point something, almost very close to 3. So somewhere here, negative 1, so it's somewhere here, very close to 3. Okay, and then when x equal to 0, so this is exactly 3. So it means that the point is exactly here. Okay, so if you continue plotting the points, say when x equal to 1, so the next value here is 1, and x equal to 1, so this is square root of 8. Okay, square root of 8. So this will be somewhere here, right? So 1, 2, 1, 2. These are negative 1. Okay, so when x equal to 2, 2, so this would be square root of 5. Okay, square root of 5. When x equal to 3. By the way, where is square root of 5? When 2, so square root of 5, 2 point something. So 2 point something, so it's somewhere here. Okay, so when x equal to 3, so this will be 0. So it would be here. So now connecting all the points, so we will have this semicircle. Okay, that's the semicircle. Now the range. So we know that the range is, we have here y less than or equal to plus minus 3. So since this is a semicircle, so if you say, for example, if you assume y, we'll use this equation here, this one. We'll use this, or is the value of y here? Okay, so let's use this value for, sorry, let's use this equation in finding the value for x. We'll take this equation class. We have this, I will rewrite it. We have x equal to plus minus square root of 9 minus y squared. Okay, so let's use this expression or equation. Now for uh, take values within this interval. When say when y is equal to -3, so when y is -3, so our x is plus or minus. So in this -3, so we have plus minus 0, but there's only one 0. So this is 0. So when you use if this -3, so -3 squared, 9 minus 3 squared, so that is 0. So it's here. Uh, when y equal to say -2, so you look at here, this is our reference. Use this interval. Okay, so when y is -2, so -2 is square root of 5, so it's somewhere here. Okay, so when y is -1, so y -1, so square root of 8, it's somewhere here. Okay, then when this is 0, so 0, so square root of 9 minus 0, so square root of 9 is 3, so it's here. And that reflects on the other side, so that's why when you, so it says that when x equal to, sorry, when y is -2, so you have two values for, I'm sorry, it's not. When you say, let's start with a negative value for y. Start here when y is -3. Okay, when y is -3, let's do it again. When y -3, so this will be -3 squared, so 9. So 9 minus 9, 0. So when y -3, x is 0, right? It's here. When y is -2, so consider this value here, -2. Okay, so y -2, -2 square, 4, 9 minus 4, square root of 5. So where is it? Where is it? Square root of 5. Ang x natin is square root of 5, that is 2 point something, right? So it's here, 2 point something, so it's somewhere here. Okay, it's somewhere here. When x equal to -1, square root of 8, square root of 8, that is 2 point something, still to almost 3, so it's here at this point. And when x equal to 0, sorry, when y is equal to 0, so when y is 0, so square root of 9 is 3, so exactly here. Okay, now if you go +1, so when y is +1, when y is +1, so 1 squared, so square root of 9 minus 1 squared, so square root of 8. So x is square root of 8, so still here, somewhere here, here, right? And when when y is equal to +1, sorry, +2, that would be square root of 5, so that's somewhere here, x is somewhere here. And when x is when y is equal to 3, so 3 squared, so 0, x would be 0, somewhere here. So we can see that the range is somewhere here. Okay, so semicircle. So therefore the range would be from 0. 0 is included. 2, 3. Okay. Any question? So I think that's all for today's lecture. Thank you very much, and see you again in our next next part of our review of functions. Have a good day, everyone. See you later.